All right. So, chapter 3 is all about exponents, and they call them surds, which is a weird word to me, but whatever. Opening problem is just talking about mass and the electric charge. Talk about your. Ugh. Okay, so a radical is any number that uses the radical sign. Be very careful. This is not just a square root sign. It could be a cube root. It could be at any time the number goes in here. If there's not a number, we know the implied number is 2. So we just say square root. These are all square roots. Or we could say radicals. All right. Surds are just irrational, which means we cannot take the square root. Okay, so square root of 2, square root of 3, square root of 5, square root of 6 are surds. We say the square root of 4 is a radical because it's underneath the radical, but because it has an actual square root, it's not a surd. I'll be honest, this is the first time in teaching IB for 6 years that I've heard the word surd, so, but it's not really that hard. Okay, so the actual definition, the square root of a, is such that if we take it times itself, we get the number underneath. So like square root of 2 times the square root of 2 is 2, because technically it's the square root of 2 squared, and it cancels out. These are inverses that cancel each other out. The square root of a is never negative, so it has to be greater than or equal to 0. Now, the square root of 0 is 0. Square root of 1 is 1. Very important. Never leave something as the square root of 1 or the square root of 0. Okay, so we can multiply under the radical and we can separate it. And we can go back and forth. If we have two separate radicals that are being multiplied, we can combine them. We can also divide. We cannot add or subtract. We can't separate that though. It's only for multiply and divide. Very important. So since square root of 3 times the square root of 2, we just multiply the 2 times 3 underneath, and we get 6. If these are being divided, we can make it into one square root and just take 18 divided by 6 to get the square root of 3. So this is just how you simplify radicals. That's really what this lesson's all about. Now, you're looking for your perfect squares. So 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared, 25. These are all perfect squares. My question is, out of all these numbers, what is the biggest number that goes into 72? So we're going to separate this into two numbers being multiplied and always start with the perfect square. 36 times 2. Since 36 times 2 is 72, we're just replacing 72 with 36 times 2. We can then use the property to separate that. Square root of 36 times the square root of 2. Take the square root. And 6 times radical 2 is our simplest form for radicals. All right. Now, I want you to think of, if I took 3x plus 5x, that would be what? These are like terms because they both have x. How do we define like terms? Everything is the same except for the coefficient. Radicals can be like terms just like x's. So if there's 3 radical 3's here, and I'm adding 5 radical 3's here, you add the coefficient and keep the like term the same. Here we are subtracting like terms. 2 minus 5 is negative 3, radical 2. So we can only add or subtract when there are like terms. So here I'm subtracting and I do not have like terms, but I can break them down. So let's think of the perfect squares again. So 75. I'm just going to write the squares. 4, 3 squared, 4 squared, 5 squared, 6 squared. These are your perfect squares. Which one of these goes into 75 evenly? So I'm going to break 75 into what times what? 25 goes in evenly, and I take 25 times 3 to get 75. Now I'm going to do the same thing with 27. I'm going to carry down my 5, break 27. What perfect square goes into 27 evenly? 9. 9 times 3. All right, now we're going to simplify. This is 2 times 5 because the square root of 25 is 5. And that's 10. Bring down the square root of 3. Minus square root of 9 is 3 times 5, 15. As soon as you simplify each of the radicals, I now have like terms. So I can subtract the coefficient and keep my like term. All right. So this is just distributing. We're going to distribute. Radical 5 times a whole number 6, you just literally put the whole number on the outside, keeping the radical underneath. Minus radical 5 times radical 5. When you multiply radicals that are the same, the radical goes away. Letter B. 6 times 1, we're just distributing. 6 times 2 radical 3. The 6 and the 2 are outside whole numbers, which makes it 12, and the 3 stays underneath. Now I'm going to distribute the radical 3. And I take radical 3 times 2 radical 3. My radical 3 times radical 3 is 3 times 2 is 6. So as soon as you distribute all of your values, combine like terms. These 6's are both whole numbers. I add them together to get 12. This is 12 radical 3 plus there's 1 radical 3 here to get 13 radical 3. Okay. All right, example 6. Be very careful when you're squaring a quantity. When you're squaring something, that means you're multiplying it times itself. So we need to distribute. 5 times 5 is 25. 5 times negative radical 2 is just minus 5 radical 2. Distribute the negative radical 2 times 5 is still minus 5 radical 2. Negative radical 2 times negative radical 2, that's a positive. Radical 2 times radical 2 is 2. Combine like terms. 25 plus 2 is 27. Negative 5, we're combining like terms. It's negative 10, radical 2. So think of adding and subtracting radicals as like terms. They have to have the same radical in order to add or subtract them. All right, last example for this section. Distribute the 7 first. 7 times 7, 49. 7 times negative 2 radical 5 is 14 radical 5. Now distribute the 2 radical 5, which is a positive 14 radical 5. A positive times a negative is a negative. Now, 2 radical 5 times 2 radical 5. We take 2 times 2 is 4. Radical 5 times radical 5 is 5. And 4 times 5 is 20. Do you see the progression? It might help you to write it out on the side and work your way to get to the final answer. Now, notice our like terms are opposites. They cancel each other out, and we're left with 49 minus 20, which is 29. Whenever you're multiplying two quantities that are exactly the same, except one is plus and one is minus, the middles should always cancel, and your radicals end up going away. That's the end of B, or A. Now let's look at B. So B is just about rationalizing the denominator, and this is pretty short. Okay. A number, a fraction is not considered simplified if there's a square root in the denominator of any sort. If there's a denominator that has a square root, we don't consider it simplified. So we rationalize the denominator by multiplying the top and bottom by the same thing. So if the square root of 5 is the problem, I need to multiply it by itself to fix the square root. What number can we always multiply by and it doesn't change the value? 1. So if I multiply the bottom by the square root of 5, I also multiply the top by the square root of 5. Because this is technically multiplying by 1. When the top and bottom number are the same, I'm multiplying by 1. Now move across. 6 times the square root of 5 over the square root of 5 times the square root of 5 is 5. I now have a fraction that does not have a square root in the bottom. I will tell you that technically this is an old-fashioned rule because we used to always do this so that we could divide numbers easier when we didn't have calculators, but this is still a thing in math. So in letter B, what is the problem? The problem is the square root of 7 in the denominator. What will fix the square root of 7? I need to fix it with the square root of 7, and I have to multiply the top and the bottom. So I am multiplying by a value of 1. Multiply the top across. 35 times the square root of 7 is on the top. All over the square root of 7 times the square root of 7 is just 7. Now we can simplify because 7 can go into 35 5 times. And my final answer is 5 square root of 7. So I think these are some of the easier ones with fractions. Probably the harder one is if there's a fraction that has a denominator where something's being added or subtracted. Okay, we can remove it. Think about that last example on A where the radicals canceled if everything was the same except for the sign. So if everything is the same except for the sign, that word is they're conjugates. I always tell people, think about what do you do to your verbs in Spanish or a foreign language? You conjugate them. Conjugates is what we multiply. All right, so this last example is just we fix the radical in the denominator if there's a plus or a minus here by multiplying top and bottom by the conjugate of the bottom. What's the conjugate? Everything is the same except for the sign. I multiply top and bottom by the same thing because I'm technically multiplying by 1. Now, when I distribute the top, this technically is 5 times that quantity, right? So we're going to distribute. I wanted to just show you that. You don't have to write this every time, but let's look at the bottom. I'm multiplying the bottom. I have to distribute. I'm multiplying one quantity by another quantity, so think of them both in parentheses. All right, so distribute the 3, 9. Distribute the 3 plus 3 radical 2. Distribute the middle, minus 3 radical 2, minus 2. The square root of 2 times the square root of 2 is 2. So I'm going to distribute the top. Combine like terms on the bottom. 9 minus 2 is 7. And that's our final answer. So this whole chapter is just getting more familiar with how to deal with radicals and how to simplify radicals.